Okay, I'm going to talk about now reactions of organometallics, specifically reactions with halides like alkyl halides, vinyl halides, aryl halides, things like that. So starting with simple alkyl halides, that's sp3 alkyl halides. The simple alkyl lithiums and Grignard reagents won't work for that. You have to use organocuprates. But of course those are usually made from organolithiums. So normally you just get a poor reaction. You might get halogen metal exchange going on, you might get a little bit of coupling, or you may get no reaction at all, depending on what the combination is. But if you add CUI, to make the organocuprate, obviously you need two of these with one of these to make the organocuprate. Then you get a good coupling. Particularly with primary alkyl halides, you get the cleanest reaction. Then you get the coupling product. So you'll find information on this chemistry on page 290 to 291 in Zweifel and Nance. So a typical reaction might be something like where you put a methyl group on the end here. Now, if you want to couple with an sp2, you can get a slow reaction with an organolithium, but really it's not worth trying. It's best to do it with a cuprate as well. So, but with an sp halide, sorry, an sp organometallic, the lithium salt or the Grignard one will work. So. And this is a reaction we actually learned in the introductory organic class. This should be a primary alkyl halide that you're coupling it with, mind, for it to work. Secondary give low yields. Also, an iodine is better than bromine is better than chlorine. And that's your coupling product. So the secondary and tertiary alkyl halides will tend to eliminate through an E2 reaction. Now what happens if you want to couple with a vinyl halide or an aryl halide, something like that? Again, you want to use organocuprates because the grignards and organolithiums don't react well, but the organocuprates do work well here. So we want to use an alkyl iodide again. So a typical example might be something like this. We can put an ethyl group onto an sp2 halide using lithium diethyl cuprate. So I mentioned in the title that you can also use triflates for this kind of coupling, and a triflate is a trifluoromethane sulfonate group, and it's also a good leaving group like a halide, and in fact we can substitute for a vinyl halide. And you may think, how on earth do we make a vinyl triflate? Well, fortunately there's a good way, starting just from common materials like ketones, for instance. So we can make an enolate and we add this compound, which is sometimes called ditrifluanoline. Its proper name is a bit confusing, so I'll just call it phenyl NFT. Phenyl NTF2, and that gives us the vinyl triflate, or alkenyl triflate, with the sp2 carbon with a good leaving group on it. And so now we're all ready to add something like lithium diphenyl cuprate. It could be lithium dimethyl cuprate. Any organocuprate will work. and we get the coupled compound there that we're looking for. Now, this is what a triple group is. It's here. Trifluoromethane sulfonyl group is very common in this class, you'll find. It's a pretty useful group. Now, another way of doing couplings that's mentioned in the book, you'll find on page 291, is also to use Fe-ACAC 2 Now this is an iron 2 complex with, this is a stabilized enolate ligand on the iron 2 compound, and this is quite a stable compound, and so you can just throw that in to the Grignard along with the vinyl halide. But the most popular way of coupling nowadays is actually to use palladium catalyzed coupling. The reason the palladium couplings are very popular is if you look, if you've got, if you have an R group here, the phenyl in this case, you have to make that from phenylithium. You also, in this case, you've actually got a Grignard present. So you may get some side reactions going on if you're trying to make these. The palladium couplings, both R groups, the R and the R prime, can contain quite reactive groups, which normally we can't have those present in Grignards and organolithiums. So I'm going to cover the palladium chemistry next. I'm going to start going through some of that chemistry.